What if I told you Elon Musk just dropped a secret clue, not about metals, not about motors, but about the future of global power itself? Copper versus aluminum? That wasn't just a tweet. That was a signal. A hidden declaration of war. Behind closed doors at Tesla, something extraordinary has been brewing. Not another lithium tweak. Not another cost-saving gimmick. But the most revolutionary battery leap since lithium-ion was first commercialized in 1991. The 2026 Tesla aluminum-ion battery. Why does it matter? Because EVs have always had a silent weakness, and no one in the mainstream dares to talk about it. It's not charging speed. It's not range anxiety. It's something deeper. Pause. Power delivery. That tiny moment when you hit the accelerator and your EV hesitates. When the numbers on paper don't match the force on the road. Lithium-ion has been failing us quietly for decades. But aluminum-ion? That changes everything. Raw sustained power. Continuous discharge without the heat bottleneck. And structural integration straight into the vehicle's body. This isn't just a battery. It's a weapon. And here's where it gets dramatic. This isn't just about physics. This isn't just about engineering. This is geopolitics. Because one truth the media rarely says out loud: China owns the EV battery supply chain. Over 75% of global lithium-ion manufacturing. Over 80% of natural graphite processing. More than half of the world's cobalt refining. And almost all of the cheapest lithium hydroxide conversion plants. If you're driving an EV in America or Europe, your battery was built in China, controlled by China, and priced by China. Even Tesla. Until now. In 2024, Beijing flexed its muscle. They restricted exports on graphite, a critical anode material. That single move forced Tesla to reroute almost $3.8 billion worth of supply chains. One policy decision, and the entire EV world felt the tremor. The message was clear. China doesn't just make the batteries. China controls the transition to electric transportation itself. And Elon Musk is done playing that game. Because aluminum changes everything. Refined in the United States. Sourced from Canada and Australia. Smelted already at Tesla's own Giga Texas facilities. No child labor. No rare earth blackmail. No sanctions. No middlemen. Abundant. Stable. Cheap. Aluminum makes up 8% of the Earth's crust. Compare that to lithium, just 0.002% concentrated in politically unstable regions. So when Elon Musk hints at copper versus aluminum, he isn't just talking about wiring. He's dropping a breadcrumb. A warning. A clue that Tesla is preparing to flip the board entirely. This isn't business. This is war preparation. Tesla isn't just experimenting. They've been quietly expanding aluminum smelting capacity since 2021. Delivering an industrial aluminum smelter straight into Giga Texas. Partnering with Alcoa and Rio Tinto to test carbon-neutral smelting technology. And filing patents for battery-grade aluminum oxide treatments. Each move was part of the same strategy. Control the raw material. Refine it in-house. Build the battery. Integrate it directly into the car. Full vertical integration. From mine to motor. On American soil. And here's the shocker. This isn't just chemistry. It's sovereignty. Tesla's aluminum-ion battery is a geopolitical missile. A way to cut China out of the supply chain entirely. No delays. No sanctions. No blackmail. Complete independence. Because whoever controls the battery supply controls the future of transportation. Think about it. Every revolution has a trigger. The steam engine. The oil well. The silicon chip. Now it's the aluminum-ion cell. Tesla's secret weapon. And Musk isn't hyping it yet. Why? Because this isn't a flashy launch. It's a quiet decoupling. A move so big it shifts global power itself. So ask yourself, is this just another Tesla upgrade? Or is this the moment when America regains control of its future? The moment when Tesla finally breaks free of China's grip? And here's the final hook. Aluminum-ion isn't just lighter. It isn't just cheaper. It fixes the one thing every EV owner feels, but no one talks about. That weakness. That hesitation. That moment when the battery refuses to give more. The secret is in discharge performance. So, is this the industry shocker that flips the EV world upside down? Drop your thoughts below. Hit subscribe. And hit the bell once, because the aluminum revolution has already begun. While every other automaker is obsessed with cramming more energy into their cells, Tesla flipped the script. Pause. Instead of just storing energy, they engineered a battery that unleashes it, like a controlled explosion. And what happens when that explosion is powered by aluminum? Pause. You get the 2026 Tesla aluminum-ion battery. This isn't a gentle upgrade. This is a discharge monster. Tesla's aluminum-ion cell uses a tri-channel aluminum flow matrix for uniform current extraction, a carbon-integrated anode mesh designed to handle up to 1,000 amps of instantaneous discharge, and new firmware-controlled surge modulation delivering adaptive bursts of power on demand. Each one of these is a breakthrough. Together? Pause. They rewrite the rules of EV performance. The tri-channel aluminum flow matrix deserves special attention. Lithium ions crawl through a single channel. One lane. Congestion. Traffic jams. Tesla's aluminum design? Multi-lane highways. 3 simultaneous ion pathways. Reduced resistance. Faster movement. And no catastrophic voltage drop when you need full power. Now brace yourself. Because the numbers are brutal. 15C continuous discharge. That's 375 watts per cell, 13 times higher than lithium cells in compact EVs. 60C peak discharge. That's 1,500 amps at pack level for 5 seconds straight with zero degradation. Less than 4% voltage sag at 90% load. 94% power delivery maintained after 10 back-to-back acceleration cycles at 70 miles per hour. No EV battery has ever done this. Not even close. To make sense of this, let's decode the C rating. 1C means a cell discharges its full capacity in 1 hour. Most lithium EV batteries? 2C to maybe 5C max. Any higher, and they overheat. They degrade. They die. But 15C continuous? That's unheard of. That's a battery pumping out relentless current without breaking a sweat. And 60C peak? That's raw explosive energy. Enough to push a single motor car into performance territory once reserved for supercars. And the craziest part? This isn't melting itself down. Because aluminum ion generates significantly less waste heat during high discharge. The ions move with less resistance, less wasted energy, less fire risk. Which means the car gets the power, not the heat. So is this all hype? Pause. Tesla's own tests say otherwise. A Model 2 prototype equipped with this battery hit 0 to 60 miles per hour in 3.8 seconds with just a single rear motor. Maintained 98% torque output during a 12-minute uphill climb, full passengers, full cargo. Towed a 2,000 pounds trailer up a 5% incline at 65 miles per hour, with peak discharge holding at 1,200 amps steady. Battery temp increase? Just 11.2 degrees Celsius. That isn't just impressive. That's unheard of. Think about that moment when you floor your EV and it feels sluggish. When the gas truck still pulls harder uphill. That moment is dead. Elon Musk just buried it. And now the story takes a wild turn. Because it's not just about the battery inside the car. It's about the battery becoming the car itself. Back in 2021, Tesla quietly filed a patent called Integrated Energy Storage System. Most people ignored it. But hidden inside was a bombshell. A battery that doesn't go into the chassis. Pause. Because it is the chassis. Here's how Tesla pulls it off. High-pressure giga-press aluminum casting, the same machines molding Model Y frames, now cast the entire battery structure into the car's body. Structural enclosures, thermal channels, electrode conduits, all molded as one. No modules, no bolts, no brackets, no glue. Just molten aluminum forming both the machine and its energy source. The battery is the car. The results are staggering. Over 400 individual parts eliminated. 72% faster assembly time. More than $1,600 saved per vehicle in labor, robotics, and materials. This isn't just a cost cut. This is an industrial rewrite. Tesla is building cars in a way no one else can even copy. Think about the barriers this creates. If Ford or GM want to replicate it, they need their own aluminum-ion chemistry, their own smelting plants, their own giga-press casting systems. That's billions in infrastructure, years of R&D. And most automakers don't have that time. Tesla just built a moat around the future. And here's the big picture. This isn't only about EVs. This is about technological sovereignty. Because whoever controls the battery, controls the car, controls the grid, controls the future. And by merging battery and structure, Tesla just gained control at every single level. So let's call it what it is. This isn't a battery launch. This is an industrial coup. A redefinition of how vehicles are powered, built, and owned. When the battery is the car, when the supply chain is in-house, when the chemistry is independent of China. Pause. Tesla doesn't just build EVs anymore. They build sovereignty. So is this the end of lithium-ion? Is this the birth of the aluminum age? Pause. Or is this Elon Musk's most ambitious play yet, a master plan to control the entire future of transportation? Drop your thoughts below. Hit subscribe. And remember, the aluminum revolution isn't coming. It's already here.